Hello, this is Ms. Benson with SanfordFlipMath, and we are looking at Algebra 2. And we're out of the Springboard textbook. And this video is on Lesson 30.1 or 30-1 on solving rational equations. So we're looking at another basic process. We've been dealing with rational expressions a lot, multiplying and dividing, adding and subtracting. So now we're going to put those all into an equation and deal with them that way. Okay, so again, we've got kind of a basic step-by-step process that you want to follow as you're solving these equations, just like we have done for our multiplication and division and addition and subtraction. The only thing that is a little bit different is that we're trying to really, we're solving for x. So we're going through the motions to make sure that we can get x by itself and equal to some value. Okay, so first of all, we're going to do some restricting the domain. That's going to come first, just so that we can, before we play with our equation, we can figure out what values won't work. Okay, what values are going to make one of our sides undefined. We're going to cancel some denominators, get rid of our fractions like we like to do, solve for x, and then we got to do some checking. Okay, so our first example is this over here, our x squared minus 4 divided by x plus 1 equals x plus 5. So first of all, we're going to restrict the domain, just so that we can have that out of the way. We don't forget to go back to our original equation and figure out which values of our x are going to make any of our denominators equal to 0. So our right-hand side, this is like x plus 5 over 1. So we don't really have to worry about restricting our domain on that side. But over here, we do have to deal with this x plus 1. So we're going to set that x plus 1 equal to 0, which gives us x equals negative 1. So since x equals negative 1 is going to make our denominator equal to 0, then we're saying that in our domain, x cannot equal negative 1. Okay, so any input values that we have, of all the input values that we can put into our equation, negative 1 will not work. It makes our equation undefined. Okay, so from there, we want to go ahead and cancel our denominators, or in this case, just our denominator. So we've got our x squared minus 4 all over x plus 1 equals x plus 5. Okay, so in order to cancel a denominator, just like here, if we have a little fraction over here, so maybe x over 2 equals 4. Well, in order to cancel that denominator, we're going to undo the division by performing some multiplication. Okay, so this allows our denominator to cancel, so we end up with x equals 8. Okay, now again, that's just a little side example to understand why we're going to do what we're doing over here. Okay, so we're going to multiply this side here by x plus 1. And if we're doing it to one side, we have to do it to the other. Okay, so in order to then, we're canceling out our denominators. Okay, so we end up with x squared minus 4 equals x plus 5. Now it's this whole, no, I didn't write it up here, so let me rewrite it. This whole side is being multiplied by x plus 1, not just the 5. Okay, so that's why I'm rewriting that with parentheses around it. Because if we have these expressions next to each other, that means, that's right, we got a FOIL. Okay, so we are foiling here to get the right side of our equation equal to some expression. Okay, so we've got our first x squared, our outsides x times 1 plus x, insides 5 times x plus 5x, and lasts we've got plus 5. Okay, so we have x squared minus 4 equals all of this. So let's do some simplifying here. Okay, so let's just make this x squared minus 4 equals x squared plus 6x plus 5. Okay, well, let's see, what can we do here? Well, if we subtract x squared from both sides, we'll get rid of that there and that there. Okay, we end up with negative 4 plus, whoops, negative 4 equals 6x plus 5. Add our 4 to both sides. This one cancels. We end up with 0 equals 6x plus 9. And you know what? I'm going through all the steps, doing the lovely solving, getting things equal to 0 in order to solve for x, because that's what we've been doing for so long with the quadratics. We could have made things a little bit easier and just solve for x up in this step here, but we can do the same thing down here in this step. So I'm going to go ahead and subtract my 9 from both sides again. I end up with negative 9 equals 6x. Divide both sides by 6. And I end up with negative 9, 6 equals x. Now I can simplify this a little bit by dividing both numerator and denominator by 3. Okay, and that's going to give me negative 3 halves equals x. So the last thing we have to do is see, okay, we've got a solution for x. We have solved this equation. We've got x by itself and have a value. Okay, that we got number 3, we did that. We canceled our denominators before. Now our last step though that please do not forget, because it's very important. It's like looking for extraneous solutions when we were solving square root equations. We have to check that the solutions are in the domain. So this value up here that we restricted, we have to make sure that the solution we got isn't that value, because otherwise we already determined that that can't be part of our domain. That can't be a solution if it's not part of our domain. Okay, so we end up with x equals negative 3 halves. That's not negative 1. Okay, so our domain restriction was that x cannot equal negative 1. So this is okay because it's not x equals negative 1. Okay? All right, so now we've got another couple examples of these rational equations. And again, we're following the same basic process the whole time. Okay? So we're going to take our first step, restricting our domain, which means that we have to set all of our denominators equal to 0. Well, these denominators are the same, so I'm just going to say x equals 0 for those. Okay, so x, when we restrict the domain, x cannot equal 0. That's one of our values. And then when we set x plus 2, here, if I go back here, this is my other denominator, x plus 2 equal to 0, so x equals negative 2, which means that negative 2 is going to make this denominator equal 0, which is going to give us an undefined value, which isn't okay. So that's one of the values that also cannot be part of our domain. Okay? So now that we've done all that work, we're going to go ahead and cancel our denominators. So I'm rewriting our equation down here. So what are the denominators in our equation? Okay, well, we have x twice, and we've got x plus 2. Okay, well, one way to do this is adding this side together first. Okay, and that's what we're going to do just because we've done some adding already. But you can also just multiply by both denominators at once, and that'll be it might be a little bit quicker, but sometimes it causes a couple issues, okay, as far as making sure that you're multiplying through. So if you can follow that wording and go at it, go ahead, pause it, see if you get the same answer. Otherwise, we're going to subtract these two values first. Okay, so in order to subtract, we first have to get a common denominator. So that means since these have two different denominators, I just have to multiply these by x over x and x plus 2 over x plus 2. Okay, so this is going to end up being x plus 2 times 2 all over x times x plus 2 minus 1 times x is x over x times x plus 2. Okay, if I simplify this first one here, I end up with 2x plus 4. And since we do have common denominators here, I'm going to combine this. So I've got 2x plus 4 over x, or minus x, all over x times x plus 2. Okay, and this is still equal to 3 over x. We haven't done anything to that side, so but I don't want to forget that that exists. Okay, so if we simplify this piece here, we end up with x plus 4. So we combine our like terms, our 2x and negative x, so we end up with x plus 4 over x times x plus 2 equals 3 over x. So now in order to cancel our denominators, we do see that there's an x here and an x here. So, but we also have the x plus 2, so we have to multiply both sides by x times x plus 2. Okay, so let's do that here. So x times x plus 2. If I do it on one side to cancel out these denominators, I have to do it on the other. Okay, so when I do my multiplication, this is like, again, like x times x plus 2 over 1. So I multiply my fractions across. I can cancel these out because they're factors that are in both the numerator and denominator. X's cancel. Okay, so what I end up with is x plus 4 equals 3 times x plus 2. Okay, so I'm going to distribute that 3 to here and here, because in order to solve for x, I have to get this as simple as possible. So I want to make sure that everything is all distributed out, so then I can deal with combining like terms and solving for x. So I end up with x plus 4 equals 3x plus 6. Okay. Now, I don't have any quadratics to deal with, so I don't have to get this equal to 0 in order to solve. I can just subtract my x's. I end up with 4 equals 2x plus 6. Okay, I'm going to subtract 6 from both sides. When I do that, I end up with negative 2 equals 2x. Divide by 2, divide by 2. I end up with negative 1 equals x. Okay, now, but we still have to, so I've got a solution. Wonderful. But I still have to go back up to the top, all the way back up here. We got our solve for x, okay? But I still have to go back up to the top and make sure that x equals negative 1 is in my domain, that it hasn't been restricted. Okay, so those are my restrictions. So x cannot equal 0 or negative 2. Well, we found out that x equals negative 1, so that's perfectly okay. So that is our solution for this equation. Okay, so we've got one more example for you. So take a minute and look at this one. This would be a perfect time to pause, see where you're at, try it first, and then come back and see if you get the same answer. All right, so just to fall in line with what we've been doing with addition and subtraction, we're going to do the subtraction on this side first before we do any canceling of our denominators. But first of all, we're going to do our first step, restricting our domain. So on the right hand side, we've got this is 1 over 1. We don't have to worry about that denominator ever equaling 0. So we're not going to worry about that. But we do have to set x plus 2 equal to 0 and say x equals negative 2, which means negative 2 will make our denominator equal to 0. We'll make this equation undefined. We'll make that term undefined. So we can't, that cannot be part of our domain. So x cannot equal negative 2. It also cannot equal, if we look at x minus 1, set that equal to 0, x equals 1. That's the other number that is not part of our domain. Okay, So now we're going to cancel our denominators, but in order to do that, we're going to do subtraction on this side first. Okay, so we've got 2x over x plus 2 minus x over x minus 1 equals 1. Okay, well, in order to subtract these two, we need a common denominator. Well, we can group these, but there's nothing common about them. So I'm going to multiply each one by, I'm going to multiply this one by x minus 1 over x minus 1. So I'm multiplying this by 1. I'm not changing it in any way besides how it looks. Then I'm going to multiply this one by x plus 2 over x plus 2. Now, since I'm multiplying by 1, I don't have to do anything to the other side of the equation because all I'm doing is multiplying my fractions by 1. Okay, so here we end up with 2x times x minus 1 all over x minus 1 times x plus 2 minus, then we end up with x times x plus 2 all over x minus 1 times x plus 2. Okay, well, I'm going to simplify these. I'm going to distribute my 2x to both of my terms. I end up with 2x squared minus 2x. And I'm also going to put everything over x minus 1, x plus 2, because we see that it is a common denominator between both of our terms. Okay, now before I forget, I'm going to leave this equals 1 out here because I don't want to forget that we are solving the equation. That's the whole purpose of this. Okay, so we're back to subtracting. When I distribute x to both of these, I get x squared plus 2x. Okay, now since I am subtracting, I have to make sure that I take care of the fact that I do need to distribute my negative to both parts of this. Okay, so in order to simplify, I get 2x squared minus 2x minus x squared minus 2x all over x minus 1, x plus 2, all equal to 1. Now when I simplify that numerator, when I combine these like terms, sorry, I lost the word there. I know you were screaming it at the screen, but I got there eventually. So we've got 2x squared minus x squared equals x squared. And then when I combine these other like terms, be careful because this is a negative 2x, and we're subtracting another 2x. So negative 2x plus negative 2x, or negative 2x minus 2x, however you look at it, that ends up as negative 4x. This is, again, all over x minus 1, x plus 2. Whew. We really will eventually get to canceling the denominators. Okay, so now we are there. We have reached that point. So we're going to multiply both sides by x minus 1, x plus times x plus 2, x minus 1 times x plus 2. All right. On this side, we have the lovely chance to cancel these. So x minus 1 is the numerator and denominator. X plus 2 is the numerator and denominator, so those cancel. We don't get any canceling over here, so we do have to do some multiplying. So this ends up leading to x squared minus 4x equals 1 times anything is itself, so x minus 1 times x plus 2. Can we leave it like that? Mm-mm. Yeah, I know you're shaking your head saying, oh, we got to do it again. But yes, you are correct. We do need to FOIL this in order to get closer to solving for our lovely x. So we just set this equal to, we've got our first is x squared. We've got our outside is 2 times x. Inside, negative x. Negative 1 times x is negative x. And our last ends up as our negative 2. Okay, so when we simplify that out, we've got x squared plus 2x minus x plus x minus 2. All that equal to x squared minus 4x. Oh, I think we're going to get there eventually. We're almost there. Okay, so we're subtracting x squared from both sides. We end up with negative 4x equals x minus 2. Okay, so if I add 4x, I can subtract x from both sides, add 4x to both sides, however I want to do it. I'm just going to subtract x from both sides and get a negative 5x equals negative 2. So then when I divide both sides by negative 5 over negative 2, I end up with x equals 2/5. Whew, we made it. All right, so are we done? Almost, promise. Okay, so we got all that work. We did our canceling of our denominators. We solved for x. Now, the last thing to do is to check that our solutions, in this case it's just one solution, is in the domain. Okay, so our restrictions are these lovely values here. X cannot equal negative 2 or 1. And is our solution negative 2 or 1? Nope. So this one checks out. So that is our summary of solving rational equations. So thank you for watching Sanford Flip Math, and we'll see you later. Bye.